Norbert Wiener defined cybernetics in 1947 as control and communications in the animal and the machine. Theoretical machines, like the von Neumann computer, presented at the first Macy Foundation meeting, which became embodied as in this modern IBM and every PC. From the animal world, networks of brain cells were first tested for their computation capabilities by Warren McCulloch and Walter Pitts, two of the Macy meetings organizers. Belonging to both worlds in the epicenter of everything important to us, the human brain. Is the brain a machine? Dr. Norman Deutsch says, the brain is not a machine. Machines do not grow and change themselves. However, from the cybernetic perspective, machines are not things, but ways of behaving. Alan Turing would say that brains are, at least, universal machines. Chris Firth says, the brain is a labor-saving device. It consumes 20% of the body's energy, so it must have paid for itself by saving muscle energy. Life is change. The brain is a device for recording changes, says Joseph Ledoux. Physically, the brain has the consistency of a jellyfish, which lacks a brain and only has a loosely connected network of nerve cells. Every neuron is more complex than any computer ever built. We have approximately 100 billion neurons in our head, and each one has about 10,000 connections to other neurons. There is nothing in the universe remotely as complex as a human brain. It has about 500 trillion synapses, and by far there are more possible interconnections in our brain than subatomic particles in the whole universe. Our brains are a recursive set of cybernetic learning machines connected by a gigantic feedback loop to the universe itself. Jeffrey Satinover says, the brain is not a single organ, but a vertical stack of them, the newer ones above the older in evolutionary order, with the latest out on top. The neocortex is a glistening, crumpled sheet of speckled pinkish-gray tissue about a quarter of an inch thick. Stretched out like a pelt, it would be about 1.5 feet wide and 2 feet long. This pelt has 6 layers, each about 25 cells thick. Our powerful frontal lobe can even imagine alternative solutions to a problem. How do brains supplement their regulatory capacity beyond what the genes gave them? From random sources and from the environment itself, says Ross Ashby, seen here at the Ratio Club. Neurons evolved from skin cells some 500 million years ago and have specialized to detect a dozen different sensations. Brain cell interconnectedness is controlled by regulator genes. They send if-then instructions to the genes in charge of directing the growth of axons. When axons reach their target, they get the signal to stop growing. Brain cells of a baby in the womb multiply at an alarming rate as neurons compete for connections. As axons reach exact locations, neurons that do not meet their quotas promptly commit suicide, and glial cells do the cleanup. Neurons are myelin insulated. Signal-carrying electrical impulses through the axons release neurotransmitters captured by dendrites located on the cell's main body. The use it or lose it rule starts applying at this level. Synapses need strengthening for better performance. Practice makes perfect. Cells that fire together wire together. Neurons form circuits and circuits form systems. Thanks to high redundancy and smart layering, these systems produce intelligence. Learning produces a synaptic result, memory. But without memory, there is no learning. Solving this paradox generates a beneficial, positive cybernetic loop. The more you learn, the more you can learn. This is what an active synapse looks like. Learning depends on dopamine-producing neurons rewarding successful synapse creation. Drug addiction ruins dopamine channels. You are your synapses, says Joseph Ledoux. People are glued together by life. Contrary to common belief, learning a language involves losing some synaptic connections and adding, keeping, and strengthening the ones needed for the specific job. Older folks find it hard to even isolate the words of a sentence spoken in a foreign language. Large systems of neurons are compulsive map makers and model makers. Our bodies, our posture, our location, our room, our house, even our possible actions. Everything gets mapped. We use this illusory world to make sense of incoming signals. This works to create a negative feedback, error-controlled prediction loop that improves with repetition. It is said that Eskimos can distinguish about 40 different kinds of snow. The fact is that perception is controlled by our current internal maps. Perception is a loop. Plenty of cognitive, emotional, and motivational processes that we are unaware of underlie our consciousness. To a large degree, culture determines what we can and cannot perceive. New cognitive systems are patchwork and modifications of old, says Gary Marcus. Gene evolution research estimates that music and language systems were added to the neocortex some 100 or 200,000 years ago. We are not born with a fixed number of neurons for life. Thousands die off each day, but certain areas do produce new brain cells. The Nun study shows the recipe for longevity. It seems to confirm that the brain cell's passion for being interconnected is pretty strong. Mapping the mind was begun by Penfield in the 1930s. He tickled the neocortex directly with tiny electrodes. In the 80s, brain scanning technologies produced color images indicating brain activity. Recognizing faces, for instance, always lights up the same regions of the brain. This type of knowledge has been piling up faster than we can assimilate it. This is a first brain research case. Phineas Gage, 1848. He recovered from the accident, but his personality changed. That left side is sequential and analytical. The right is simultaneous and holistic. When Dr. Taylor suffered a stroke on the left hemisphere, her right side made her feel being one with the universe. Phantom limbs are evidence of the brain cell's eagerness to connect. When a fake arm placed on a table is scratched simultaneously with the real arm hidden from view, after a while, scratching the fake arm only will be enough to produce the scratching sensation. The boy who can see with no eyes is more of a Batman than Bruce Wayne. Having blind faith in his mother's words, he learned to see images by bouncing sounds off different objects. Artificial life research and complex adaptive systems at the Santa Fe Institute will help study how collective brains work. Is the mind a product of the brain? What about recent discoveries that the content of the mind shapes experience and the experience shapes the gene expression that shapes our brain? The Cartesian body-spirit duality continues to be an appealing metaphor. Even genes have a dual nature. They are templates for protein creation and also a guide as to when and where that protein should be built. Computers and software, brains and minds, doers and managers. These three outstanding cyberneticians saw the brain as an intermediary between the real world and ourselves. Consequently, the cybernetic scientific paradigm embraces this kind of relativity. According to Ashby's definition, systems are lists of variables we isolate, not objective facts. We see with our brains and with our minds, and not with our eyes. On the road to Damascus, St. Paul suffers a stroke and becomes enlightened. Matthew Alper says, just as every culture from the dawn of our species has perceived the world musically and linguistically, every culture has perceived the world spiritually. We still ignore a lot about how the brain works. Is our brain a quantum computer that allows us to transcend our mechanicality? The human brain is the universe's biggest achievement, only possible on a planet like Earth, and just the right size too. Maybe the purpose of the universe is to contemplate its own existence through us. It has about 7 billion brains from where to choose from.